Hi, Science 30s. It's Mr. Riley here, coming to you from my basement. And another episode of Science 30 here, and we're talking about electrical energy. What we're going to look at today is something that's called Watt's Law. And you guys might have heard of Watts before in terms of electricity. We're going to define what that is and learn some things about it. These are a couple of different terms that you probably heard before, but maybe you don't know exactly what they mean. So we need to define these first before we can move further. The first one is current. And current is the flow of how much charge passes a point per second. So sometimes we look at current and we think of current as the flow of charges. So in terms of electricity, it's how many coulombs of charge pass a point every second. So we, instead of saying coulombs per second, we actually call current, we use a unit called the amp. And 1 amp is 1 coulomb per second. Now current, it's kind of weird. The symbol is I. I mean, I guess C was taken. So the symbol for current is I. The units are amps. And an amp can be shown as just a capital letter A. Now voltage, I mean, you guys have all heard of voltage, but what exactly does it mean? So voltage, the symbol for voltage is V. That's nice. Sometimes we describe, when we're talking about electricity, we describe voltage as the push or the amount of energy that's sort of behind each charge. And so 1 volt of electricity, or voltage, 1 volt of voltage is 1 joule. Now you guys might remember joules. Joules are a unit that we use for energy. So it's how much energy. So it's 1 joule of energy per coulomb of charge. So it's how much energy each charge has. Now, when we combine those two, current and voltage, we get power. And power, the symbol is P, is the rate of how much energy passes a point every second. And so the units we use for that are watts. And a 1 watt is 1 joule of energy per second. So the formula we're going to look at today is something that we call Watt's Law. So let's just look at Watt's Law here for a second. So let's say I take 1 amp of 1 amp of current, and that is coulombs. So 1 coulomb per second, and when we multiply that by 1 volt, and a volt is a joule per coulomb. And we see what happens when we multiply this. So this is your I, is your current, this is your V. When we multiply these, coulombs cancel out, and we get joules per second. So when we combine voltage and current, we get power. And power is a measure of joules per second. And the way that we say that is watts. So if you guys go on your data booklet on page 3, we have some information for you. Here's the formula, Watt's Law, that we'll need to use. And then there's your symbols and your units that we're going to need to use. So let's just look at an example. So here's an example. A light bulb draws 0.25 amps of current from a 120 volt household outlet. What is the power required to run that bulb? So how much energy every second do we need to run that light bulb? So my given information here, I have 0.25 amps of current. Okay, so current, I got to go look up and remember, current is I. So that's 0.25 amps. My voltage is V. So that's 120 volts. And I'm going to be looking for power. And I'm going to use Watt's Law here. It's P equals IV. For 3 variable formulas, I will expect that you guys are able to manipulate that for any of the variables that are there. So I might ask you to solve for I or V. And we're just going to plug our values in here. So I'm going to get 0.25 amps, multiply that by 120 volts. And when I do that on my calculator, I get, 30. And the units for power are watts. So my light bulb requires 30 watts of electricity in order to run. And so there's a little bit on voltage, on current, and on power, and that's Watt's law. Okay, good luck.